Welcome back, ladies and gentlemen. We're diving into 3.5 Day 1 trig functions. We're going to be finding derivatives of functions involving the 6 trig functions. There you go, easy enough. Alright, well, the trig derivatives, the derivations are a little bit complicated, but if we go with the following, showing graphically that the limit as cosine of x minus 1 all over h, and if you kind of look at the graph, this hopefully obviously is the graph of this particular function. And notice how as h approaches 0, this guy becomes a 0. Okay, following up on that, the limit of sine of h over h as h approaches 0. Okay, notice the curve right here goes right through 1, so the limit of this guy is 1. Alright, now if we have those two things, we can do the derivative of sine. Alright, well, the derivative with respect to x of sine is, of course, by the definition of a derivative, limit as h approaches 0 of sine x plus h minus sine of x all over h. Alright. So let's start messing with that. Alright, we got the limit as h approaches 0. Okay, now I've got the sine of a sum, and we have a formula for that. Alright, so sine of the first, cosine of the second, plus cosine of the first, sine of the second. Alright, so that's what basically the first half of this becomes. And then just minus sine x, of course, the original function. And this guy's living all on top of an h. Alright, let's see if we can do a little something meaningful with that. Okay, so basically I see a sine of x in the first term and a sine of x in the last term. So what I'm going to do is rearrange these guys and put those two terms next to each other. And if you'll permit me to do so, not that you could stop me, I'm going to also factor the sine of x out of each of them. So I get the sine of x, and then I have a cosine of x, or sorry, cosine of h, minus 1 left over from that. And then I've got this other term, cosine x sine of h, that doesn't have much in common with the other one. Alright, that guy's still on top of an h. Okay, now the wonderful thing about fractions is if I've got multiple parts of my numerator over a single denominator, I can break it up into multiple fractions. So that's what I'm going to do right here. So I've still got the limit of h approaches 0, but I'm going to break this up into sine of x times the cosine of h minus 1 all over h plus the cosine of x sine h all over h. Okay, now with a keen eye you can see those two things I mentioned in the previous slide. Alright, so what I'm basically going to do is break this first fraction into a multiplication of two fractions, first of which being sine of x over 1, and then kind of the other stuff now is the cosine of h minus 1 all over h. And that should look very familiar to the previous slide. And I can do something very similar here. I'm going to pull the cosine of x out as its own fraction and write that as a multiplication with sine of h over h, again, right from the previous slide. Okay, so basically at this point I can apply the 0, the limit as h approaches 0, because this from the previous slide is equal to 0, so I have sine of x times the limit of this guy is 0, so that effectively becomes 0, plus the cosine of x, again this guy effectively becomes a 1, so after a little bit of pretty simple simplification here, you get the limit eventually equals cosine x, so basically what that says is the derivative with respect to x of sine is cosine. Now, in case you're interested, I could do something similar for the other 5 as well, but I'm guessing you'd consider that torture. So without any more of that torture, all 6 trig derivatives are summarized here in the table, and yeah, you gotta memorize those. So take a second, pause the video, take it in, deep breath, there they are. Alright, so knowing those derivatives allows us to do derivatives of various functions. For instance, if I've got y equals sine of x minus cosine x, well, if I want to know the derivative, then that's y prime equals, well, the derivative of sine is cosine minus the derivative of cosine from that chart that I'm sure you already have memorized is negative sine. Alright, so just cleaning that mess up a little bit, you get y prime equals cosine x plus sine x. Which again, remember, just allows us to figure out the slope at any point in that curve. Okay, moving to this other one, just don't panic if you have a mix of non-trig things and trig things, just the stuff that we've done before is useful for us. For instance, this 4 over x, what I would personally do with something like that is write it as 4x to the negative 1, and and then leave the cosecant right where it is. Notice I did not say y prime, so I'm still messing with the original function. But now that it's in a much nicer form, for derivative purposes that is, I can now take the derivative, and I get y prime equals, exponent comes out front, gives me a negative 4, x to the negative 2 now, and then minus, okay, and the derivative of cosecant is negative cosecant x cotangent x. And then again, just cleaning up the mess, y prime equals negative 4 over x squared. Again, I just do that because the original problem was given in that sort of format, so I'm keeping the format of the original problem. And then 2 negatives make a plus, so then I got cosecant x, cotangent x. And I'll do that derivative. Okay, hopefully that didn't look too bad. Alright, and then functions similar to the one I have here is the first time that realistically the product rule has to come into play, because previously everything we've had could have been simplified to a single polynomial. But now with the introduction of trig, you don't have that possibility all the time. So basically here, using the product rule, I've got y prime equals the first times the derivative of the second, and I'll just write this out fancy just to help stress exactly what's going on, plus the second times the derivative with respect to x, I'll do first. Right, so my x to the third stays right where it is, the derivative of cosine is negative sine. And then the cosine stays put, and then the derivative of x to the third, of course at this point, is 3x squared. Okay, be careful you don't let this guy interact with the x, which is part of the cosine. But as a final cleanup, we've got negative, this negative sign comes out in front, is probably the best way to write this. Negative x to the third times sine of x, plus 3x squared times cosine x. Alright, if you wanted to, you could factor out an x squared or something like that, but I personally find that unnecessary. So there you go. Alright, and there's the assignment. Even numbered answers right here. Other than 16, they do ask you to do some kind of proof stuff, so I'm going to leave you on your own for that, because obviously if I gave you the answer, some of you would just be lazy and just copy it down. Oh, I don't know, none of you would ever do that. I'm sorry. Didn't mean to mention that. Alright, anyway, as always, hopefully that made sense, and if you have any questions, please ask me when I see you in class. See you then.